Okay, alright. I've been meaning to do this stream for a few days now. So, we're going to take, it's going to be a basic stream really. It's just a lot of wiring and then maybe some coding for the PID control. We're going to take a breadboard, a Raspberry Pi Pico, a Pico W will do as well. We're going to take this chip, which is a magnetic encoder that functions with 4 Hall effects switches. Oh, I'll also say, let me do this. This is a big shout out to the person that really made this, did this first. Oh yeah, it's right here. It's this guy. But he seems to only have Arduino solutions to it. But he has he made his own PCB and everything. So, anyways, we're just going to be adapting this to my own setup here, and we're probably going to design the bracket ourselves. And the only reason for that is, and so, anyways, let's get started. Okay. So here we go. We have the Raspberry Pi Pico. This is a Pico W, but both should be fine. This is a NEMA 17 stepper motor. Okay. This is a motor driver. You can get like 4 of these for like $10. And I actually, for the first, for basically never do this, but I actually have a stream schedule of things that we're going to do today. So the first thing we're going to do is we're going to open up this motor controller. And it comes with a heat sink because these things do take some power. So what you want to do is peel off the adhesive protection. And just place it on there. Okay. Now, I forget which way I like to do this. I'm pretty sure we want step and direction right here. Okay. Oh, let me, okay. So, oh yeah, so I forgot to mention, you probably will need a soldering iron for this. So the whole list of things I think will come up in due time, but let's just get this thing wired up. So, let me move this. And what I'm going to do is, all right, so I believe that this is my schematic for the full thing. I want to compare really quickly with, what does the Education Edition get you? I believe this is the old one. It is the old one for sure. How do I zoom in? How do I pan? Okay, so I believe that all we have to do is yep, okay. So I just wanted to make sure that the orientation was correct, and it does match up to this. So now I'm going to switch back to, actually I want to use my phone to do this, because I got OBS Blade and I'm cool like that. Awesome. So so let's just get started here with getting some wires put in. Let's make sure that I can zoom in more. Well, no one's gonna come into chat, but I think I really wish I could electronically control the zoom, especially for this new lens that I got. But whatever. Oh, and one thing that is indispensable is some wire strippers. You're going to need those. Okay, ground. Okay, so we need to think about power as well. So let me... So the reality is that these stepper motors don't really draw a lot of power, at least with this driver. But you do want to be careful about how much current you're going to draw. Also, so this is going to be my power supply. Basically what we do is whenever we get electronics with one of these wall warts, we save it. And I advise you, if you have space, to save them, because it's always nice to be able to cut one open and use them for a compact power supply, because it's a pain getting out the variable or even the DCs. You know, it's just annoying. One thing I am thinking about though is maybe I'll get a terminal block so that I can screw this down, because these things have a tendency to fall out. So I'm gonna go get my set of terminal blocks at some point. We're not really ready for this, but at some point we're gonna make a call on whether or not to do that. So we put in the ground, and then we're gonna put 3 volts all around, because the only thing that needs 19 volts or 12 to 24 is one of the pins on here. So we should be good with that. Okay. I'm gonna get my mouse really quickly. Okay. Now middle mouse button does what I want. Okay, cool. So right, yeah, so a 4-pin header goes there. So that's good. That goes to the driver. These 4, and then more ground, and then that's the VCC. So let's ground that one. Let's see. We made it go all around here, because we flipped it around, I believe. How many pins do we actually use? Do we use all eight of these? Yeah, I guess we do. 1, 2, 3, 4, 5, 6, 7. These are digital general purpose pins, though. Okay, I always get hung up on this and like how to do it correctly, but what we're gonna do, first off, I'm just going to do new project or something. How do I do a new project? Oh wait, hold on. How about new schematic? Wait, what just happened? Dude, why are all of these so bad? Oh, they're different sheets on the same thing. Okay. So I just want to copy this and this. So wait, we're going to copy, paste. Oops. Oops. Paste. Okay. And this is just to basically get me... Oh wait, let's do this. Move these over there, and then can we just... Oh, dude, it's actually hilarious just how bad EDA software is. I swear to God, I could write my own better in a week. Oh, but what about this? What about that? Yeah, what about lick my balls? Okay, then we gotta delete some of these cues as well. Or the run is a, oh, it's not Q in here. What is it? Oh, it's nothing. Okay. All right, so what we're gonna do is just, we're gonna go bottom to top. So we're gonna put this here. Do we really want to do all this for microstepping and all that? Whatever, I'm just gonna do it. Because then we'll at least, because I'm just gonna keep this breadboard like this so that whenever I need a little demo, that's the thing is I rarely, I feel like I want to just buy more breadboards as opposed to having to keep disconnecting them all the time. So this one's just gonna be the breadboard that I use to. But like realistically, I don't need to connect all of these. These are the only two that actually matter. And we're going to find out if connecting them to the ADC works. My guess is that it does. All right, so let's just start plugging away now. Okay. So I'm just going to cycle the colors. I really don't care. So let's switch to this, and then let's see what it actually looks like. Seems fine. So I'm just going to cycle the colors because they're all pins, and I just want to see that they're different. Make sure they're the same length, too. That seems good. Okay, then red. We just need 8 wires. 2. 3. 4. 5. 6, 7, 8. All right. I was thinking yesterday a lot about touch perception, and I was reading this stuff from Meta AI. On they released some, you know, visual encoder for like touch perception information, and it seems really cool. There are a couple companies that are using their model to develop some, you know, high fidelity hand robotic hands. But my guess is that they're going to be all really expensive and like more, you know, industrial, non DIY things. So I want to see if in the future we can do something with that. I was also thinking the next best thing, or the thing that's way better than that actually, is you I always hate this. I'm just gonna get the vacuum later and vacuum this up. Is what you do is you grow a bunch of Merkel. They're called Merkel cells, and they're what give our fingers and, you know, our body's touch perception, I think. Okay, so let's start from the bottom. So this is the enable pin. I'm just going to go to this pin. Okay, then this pin. This is the microstepping. Okay. Then the microstepping. Then the microstepping. Oh wait, I fucked this up. Yeah, that's ground. We should just add ground to all of the grounds. How many more grounds are there? So we put in 1. But we should put in 1, 2, 3, 4, 5, 6, 7 more grounds. Just so that we know which pins are ground, because then I don't have to keep worrying about it. Okay. That's probably... Seven is right, yeah. So I cut these long, but who cares? This thing gonna be fitted up after this. Fitted up with all its grounds. Okay. So it's the third one down, right? Can we just look up the pinout? Pico W pinout. There we go. Yeah, it's the third one, the 8th one. Okay. So where did we put that thing? I lost it already? What the hell? It's so easy to lose. Oh, there it is. Okay. 1, 2, 3. I think this one might be a little bit too short. Yeah, fuck it. Yeah, that's good. Okay. 8. Eight. 13. Okay. 18. Okay. All right, now, okay, 8. All right, and then 33 is the last one. Not long enough? It might not be long enough. That's not long enough. God damn it. That's definitely good. It's okay. Now we can just indiscriminately start adding our wires. Because we can't really fuck it up now. So that's microstepping 2. Okay, so then what we want okay. No, I always forget. dir is on top. Okay, so we just want to encode this information into a dictionary or something. Make this one a little bit longer. Okay. So that is the number that we refer to them by. Okay. All right, cool. So now I'm going to get the terminal block, and we're going to power this thing, and we're going to test it out. So maybe it makes sense to switch to the okay. So let's see if we can get a close-up here. Unfortunately, I can't trigger the autofocus remotely, really. Okay. So, okay, so I need to get just a couple of things. Terminal blocks and then the headers for this. And with that, we should be able to test our stepper driver and just make it move. Okay. I'm also gonna get the vacuum. Okay. Oh, I need some screwdrivers as well. So I'm just gonna. Yeah, that's the right way to do that for sure. Okay, so we have one of these, and we can put this in, and we need to make sure we get it right, but it's pretty hard to mess it up. You can actually, it's probably better to put it in here. So now I have just converted it to a plug that I can plug it in. So we're pretty much there. We're just going to need some power here. So we're going to take one of these. We're just going to, how do I want to do this? I probably want to do it like this. Or maybe, yeah, we'll do it like this. So we plug it in here like that. And now, and actually the thing that we want to do is we want to keep it, when we do this, we're not going to unscrew it from here. We're going to keep it on here because this is the right way to do this. And so, doesn't really matter. Oh, let me get the screwdriver. Okay. All right. Let's clean some of this up. All right, that looks a lot better. So what you're going to do is screw them in. Oh, they're probably tightened down right now. Loosen them up first. Now, I hope it goes without saying, but you really don't need these terminal blocks. And a lot of this stuff that I'm doing right now is purely to make things a little bit easier on me, but it's not stuff that you actually need. So anyways, there's our power. So our 19 volts is going to come into one of these terminals. And the ground is just right there. And so we are just going to ground this thing really quickly. And in this case, and in pretty much most cases, you're going to want a common ground. So the ground that is connected to this wall wart is going to be the same as the ground for the Raspberry Pi Pico. Okay, now we just kind of need to make sure what it's actually on. Yeah, it's on this one. Cool. And then now we just need a small red wire. Okay, now this is the last thing, really. One thing I find is, this is kind of a handy trick, is you can just pinch it, and then this allows you to keep the wires parallel, but actually narrow it a little bit. Useful trick. Okay, there we go. All right, so now we have power, and we have all the digital stuff set up. So now I'm going to do a little bit of a walkthrough in the code. And by that I mean I'm going to like go and find my old code and just copy it. All right, let's go here. And I believe it's called stepper all pins. And so basically we have a okay, so I'm just going to copy all of this. I mean, really, we can use this code. I think I want to make a new repo, kind of. Just because this is so messy and it would be nice to have it. So let's just say make their closed loop stepper. Okay, so we can delete this. Oops. And we need to fix these pins. Okay. So let's look at our schematic here. Okay. Enable is 16. Microstep 1 is 17. Microstep 2 is 18. 19. Reset is... Wait, I did something wrong. Whoa. Okay. Wait, no, that must have just been a mistake from me copying it over. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, okay, so we're good. We just need to delete this. Oh, God. Is there a way to detach it? Jesus. These things are so bad. It's kind of insane how bad they really are. Okay. Can you hide this thing? Great. Okay. So we just want to check that the pin above... Oh, wait. That's actually a good point. We never actually... Okay, so yeah, so we did make a mistake here. So we're going to have to fix this. It's... 2 above that ground. Which ground is it? It's the second one. 1, 2. So this blue one needs to be up here. Is that it? I think that's it, right? So we could just check that. Okay, cool. So I think we're good. I'm glad I caught that. So let's go back to the code. And so reset is on 20. Sleep is on 21. Yes, step is on 22, and then this is on 26. And I'm going to actually just quickly ask ChatGPT. Okay, thank you. On the Raspberry Pi Pico W, there are some like ADC pins. Can I use those as normal digital pins if I don't want to use the analog digital converter? Okay. Fantastic. So then we should be good to test this thing. So, okay, so I'm going to show... oh, and I guess one thing that I kind of glossed over, I'd like to show this in detail a little bit, is this stepper motor has 4 colored wires, and I just happen to remember that the blue one goes at the bottom. I've just done this enough that I remember that, but like, you need to check if you're actually going to do this. You need to check that. Okay, so now we just need to get a cable to connect this to the computer, and I'll show you how you can control the stepper driver. One thing we need to do is we need to plug this in. So I'll plug that in as well. Let's make sure these are nice and tight. Okay, I can't imagine that I break this because this seems like everything is correct, but you never know. But so that's why we're doing this. So. Okay. Okay, we're gonna get rid of the mouse for now. Okay, so the way that I do this is okay. Oh, and the driver that I'm using, not that it matters. You know what? If you just look up NEMA 17 stepper motor driver, it's the red one. It's from High Let Go. Honestly, their documentation is terrible, but who cares? Anyways, more importantly, the way that I do this is I have an extension called Micro Pico, and a Micro Pico is awesome. If I go to a Python file and I do connect, I have a thing here. And so just to test that this is working, what we're going to do is from machine import pin, and then LED equals pin, I think it's just LED, and then comma pin dot out, and then we can do LED dot value 1. And then if you can see here, the LED has turned on. So that's a little test that that we're actually doing something and communicating with this this machine. So now what we can do is we can just click this run command, and to go over this code very briefly. So what we've done is we've just set all of the pins, and then we've set their default values. So we've basically disabled microstepping, and then some of these pins are inverted. So when enable is 0, it actually means that it's okay. So when enable is high, then the machine stops. I forget about sleep and reset, but the two more important ones are dir. And dir will be changed. All of these other ones are pretty much not going to be dynamically changed, but it's only in case that we want to. Oh, and I guess we use the enable on a keyboard interrupt. Okay, yeah, and then we just have this simple function called test stepper, and it just basically steps it, and you need to step it with a delay. You can't just set it to high. I'm pretty sure something weird happens if you just set it to high. But let's try to run this thing and see if it works. Oh, we have to plug in our power supply. Okay. Oh, yeah. So let's go to the camera. Let's see if you can see that rotating. You can barely see it rotating, but there you go. It's rotating for sure. So that's basically the first objective of this stream is done. Is we wired it up and we stepped it. We used the wall wart for power. Now the next step is to design the mount, and so it's time to introduce the next component of this whole charade, this whole day. Okay. You gotta be careful because it comes with a little magnet. Okay, so this is the as5600 or something. I got like a 4-pack on Amazon for pretty cheap. It also comes with some headers, so we're going to be soldering these headers onto this thing. And then this is a very special thing because when I try to find these diametrically magnetized magnets, so most of these tiny little neodymium magnets that you'll find are polarized in the other direction. And so the thing is, when the line is going down, basically if you were to draw a dimension for the diameter, that's where the axis of polarization is. And so as this basically 4 Hall effect sensors rotates above this magnet, it actually can sense a change, whereas if it was polarized the other way, basically that orientation wouldn't matter at all. So this magnet's a little bit special, so I would take care to not lose it, but I still want to find on Amazon a source where I could find these little magnets and buy a pack of them just in case I need some backups. But you have a 4-pack, so if you lose one, it's fine. All right, so what we're just going to do is solder this together, and then I have a little bit of super glue. And I've never really used super glue on my own before, so that'll be interesting. So what we're going to do is put these in here from the back. And then we're going to hold it up like this and solder it. And honestly, the trickiest part about this is making sure that you get them nice and level. One way you could do it is you could put a little bit of super glue or something and then hold them down just for a bit, or something fast acting. In any case, one thing that I highly recommend everybody get is not a third hand, but it's one of these like flexible, it has like a bunch of hands on it, and it has like this big rubber base. It is an extremely useful tool. It's probably the best soldering tool that I actually have. So we're just going to come down, do this, and then I'm just going to get this up high so that I can get from under it and just solder onto it. Okay, so let's get our soldering iron set up here. And plug it in and heat it up. Heat it up. Heat it up. Okay. So we'll just wait for a minute. All right, so just to go over the next steps here. So we're going to design the mount. I kind of want to do all the hardware at once and then all this computer work later, because then I don't have to keep switching back and forth. So yeah, we're going to glue the magnet on. Oh, I need to get some toothpicks. We're going to solder the breakout headers. Then we're going to attach the sensor mount. And so one thing I guess maybe is worth going over. I need to get another screwdriver really quickly. Okay, so I didn't actually do this until a couple days ago, but it turns out that if you take off the sticker on your stepper motor, it exposes the rear side of the shaft, and the shaft goes all the way through it. I don't know if you can see that turning, but it is turning. And so that's sweet, because then you can build something onto the back of this and not have to do some random thing to disturb the shaft. Because otherwise you'd have to I don't know, getting it away from the part that you're actually using is really nice. And so you can take these off. And again, this is huge props to that Curious Scientist channel on YouTube, because he really did an amazing job. One thing that's a little bit problematic here is, yeah, we're going to need... Okay, it's dawning on me that I'm definitely going to need some longer screws. This is going to be one of these specialty things. So I brought some calipers with me. I guess this means that we're going to kind of have to end the stream a little bit early. Maybe I'll just design it in a different way so that we can test it. But oh my god, they're in inches? What the hell? Who the hell uses inches, bro? 2.59. 2.9 for the major. So they're probably M3s. And then how long are they? This is going to be annoying because it's so specialty. What I'm thinking we might do... 42. Yeah, so this is about the length of this whole thing if you go to there. Yeah, so, okay, so I think my plan is to just avoid having to buy anything, because That sounds like a pain, and I want to get this done. So what my new design, I'm probably going to make um, a compliant mechanism that allows me to get over having to. So my strategy here is once you get it down, then you can kind of hold it down. And once you have one, it's perpendicular, but you want to make them straight up and down. That's good. Okay, now that I've done that, I can just do the rest in a way that's like easy for me. I do want to get it in the shot. Let's see, what if I do this? There you go. Oh no. There we go. No, there's still a short there. Frick. There we go. I honestly can't tell if I have it. Okay, now I just gotta move this around here like this. It's fine. It's fine. Okay, so now we could just test this thing and get this thing working. That's pretty much all the soldering that we actually have to do today, so I'm going to take this and get it out of here. Okay, so let's see here. Okay, so we might as well put the magnet on because now the magnet is loose. All right, so I've never used this stuff. Are there instructions on here? All right, maybe I'm gonna get some gloves. I'm gonna get some gloves and some toothpicks, and then okay, then we're gonna use this little piece of cardboard with a weight on it. Well, this weight is no good because we actually have to hold this, so we need to let's put this on there. So we can take this out right now. So what we want to do here is we're going to take a toothpick, dab some on there, and dab on this thing. And it, oh no. Oh no. Okay, wait, we need to get something. We need to get something strong. Because the problem is I took out all 4 of these screws and I couldn't get this thing, so it's like sealed. This is not going to be good. You need something with like a hook. What if I just try to... No, it's too wide. Okay, we're kind of in a bind. Let me see if I can use another magnet to extract it. Okay. So a while ago I bought a kit of magnets. And I really haven't used them. Oh, it's way too weak. What if I tried like the whole box? Not even close, man. What a waste. Okay. Let's see. So we need... Damn. I wonder if I can just pry... Alright, I think I'm going to look up a YouTube video to see if anyone has opened up a... opening NEMA 17. Should I try to force it out? It seems like mine is sealed together, though. I don't know. We have to try, basically. I mean, it's going to be way easier for us to actually install this thing if we do take it apart. Plus, these things are only like 15 bucks. This is the wrong one. There we go. All right, so I just feel like it's totally sealed. It's so annoying. How are we gonna do this? I'm kind of tempted to break it, but ugh, come on, bro. That's what I was thinking. It would be nice to build a jig to put it on. You know, print out a little thing for it. How the hell are we gonna fix this problem? So you can see here, it's off center, and there's just no way to pull it out. I'm wondering if I could take some tweezers. Maybe some tweezers would do it. Okay, so I got two tools to try to fix this. I got some tweezers. There we go. Tweezers worked. Easy as pie. But what I think I'm going to do is we're going to design, so I actually want to put this somewhere safe. Oh God, it's so easy to lose these. I'm actually gonna, okay, for the time being, I'm just gonna go put it back in my little drawer because I know I'm gonna lose this. It's just guaranteed. But so, just a precursory thing on how I'm gonna do the design. So, the first thing is, we are gonna rely on these small notches. Considering I can't take this apart, and considering I don't want to buy new ones of these, it pretty much dictates how I'm going to do this. So in any case, I'm going to put this magnet away so I have peace of mind and I'm not constantly trying to find this. Because I could just put it here, but it's like, I don't know. It's just, it's not going to, you know. Okay, so with that, we're gonna probably push that back. Let's see. I mean, no, we're kind of at that point. So let's just start. Let's just hop into CAD, I guess. Yeah. It's actually nice that maybe to install it, you don't have to. Okay. So let's. We're not going to be using the breadboard for a long time. We're going to put this in here. Okay, so now it's installed just so that we don't lose it. Okay, we can unplug the power supply. Put this in our project box. Okay. Okay, so we're going to put this back on. That's what we need. All right. I feel like this thing may come off, but I really don't want to force it because then I'm just like, I just broke something. Because it does look sealed, but all of the other ones seem like they come apart. I wouldn't be surprised if it's just adhesive that you have to break and it is actually separate parts. It almost certainly is separate parts. Okay, so now we have a pretty well-defined prototyping task ahead of us. And we just need to... So what I'm thinking is maybe... There's two high-level features of what we're accomplishing right now. There's the fact that it needs to mount the sensor. And actually, I am going to go look at Curious Scientist's... All right, so yeah, so basically the tools that we're going to need are a calipers and our model. which is, you know, it's always fun when you just get to, that was loose on there. Was that loose on there for a reason? Oh, shit. Okay, well, I guess I just opened this thing. I forgot that I think if you tighten that thing, it punctures it. I don't know. Maybe this thing was already open. Anyways, let's hop into CAD. Let's do it. It's CAD o'clock. Oh, shoot. If Microsoft products have no haters, I'm dead. Okay. Let's just, okay, wait, let's go. Let's just close this whole thing. Oh, wait. We want to save that. What? A joke. There we go. Okay. Please be logged in. I'm almost certainly not logged in. Oh, yeah, hell yeah. Okay. No. Okay, okay, so what we're just gonna do is, so let's do, and this is going to be, oh my gosh. That is the worst feature of Onshape for sure. Okay. So we want to do a rectangle. It's like, let's just do 0.15. Oh wait, why don't we just add it to that thing? Why make another thing? Oh wait. Why do they make the smallest text box ever for this thing? It just makes no sense at all. If you're typing an expression, yo, Onshape is actually kind of trash. Seriously, Onshape is kind of trash. Not to be a hater or anything, but it is. So let's just make it this. Oh, you can't click on it either, dude. It's so stupid. Implicitly make a dimension for it. Okay, we're just gonna do okay, so what we want to do is first, oh, I kind of messed this up anyways. We, so we're going to have to tune this a lot. But for right now, I just want to get the first feature down, which is Honestly, it could be 2. What was this? 42.62. So how do we want this to go? So we need this to be, we have stepper, but I'm going to measure it too. Okay, so it's 11. So we want to extrude this by 11. But the thing is, okay, so let's just do that. Yeah, so let's make it, maybe we only want to have 2 clips. I think we probably only want to have 2 clips on it so that you can pull it out. So we don't want it to go all around it. Yeah, so maybe it's like, okay, so first off, let's rename this to be, oh, oops. Okay, and we're going to do an assembly. We're going to rename that to be encoder mount. And then so let's fix this. Right. You can't fix the whole thing because there's a Revolut mate, but you can fix this. So now you try to move this, you can't, which is great. So let's just try to mate the center of this to that. Okay, so the idea is we're basically just going to have a little clip come out from 2 of these corners and go over it. So you pull them out. So we do this. Oops. Should get 11. So that says 10, but it's definitely 11. So I'm going to trust the calipers. I'm not going to trust the model. It's like 10.8. You do want it to be pretty tight on there, though. So we're going to have to, that's maybe like a, so I'll make the overhang at 11. Because I'm measuring pretty reliably 10.8. Okay, so what we're going to do is, what we want to know is the distance from, I guess, this edge to this point. But we want to get the wait, what? Wait, how is that the minimum distance? I wish we would keep it. Oh, yeah, for sure. So, so these are the magic numbers. So if you were to go normal to this, I wish you could sketch just to like get things right. This yeah, it's this edge. Okay, cool. So it is, so that's nice. I like that. I wish I could lock in that point where it intersects. But it seems like it's 3.6 and 3.6. So let's just try to draw a point there. Let's edit this sketch. So we need but that's driven, right? Yeah, okay, cool. By the fact that that's a right angle. So now we want to say that the distance between this point and this point is 3.660. All right, so I'm pretty sure that's wrong because the distance from oh shit. Because that was that was yes, if you have a triangle, you need to go 3.6 this way and then 3.6 this way, right? Okay, whatever. Let's take this and extrude this by sure. And we just want to see, because there's definitely a big gap, right? Oh. Wait, when we do this mate, can we edit this mate? Oh, shit. Oh, the distance from this point to this point. But that's not to the center. It's 5.2, but I think it's 5. I think the 0.2 is coming from the Z. Is there a... No way. It's going to take forever. Oh, shit. They said the min distance was 5.2. All right, so that's what it is. So let's do 5.15. All right, let's get out of here. Roll this forward. Sketch. I'm going to delete this. This is going to be 5. Okay, so now, yes, now we do that, and let's just look at what it looks like. Do you plan on showing up, or here we go. Parallel distance 0.37. All right, so let's just make it 0.3 more. What just happened? What? Oh, I must have accidentally deleted it. Okay, so let's finish off the feature, I guess. I guess we're going to sketch on here. So we're going to make a little clip. So let's just make it a little overhang thing. Yeah, we'll make this 3. We'll make the distance between here and here. This is going to be 11. Okay, then we're going to extrude this, and we need to actually know how much to extrude it by. So we want to know from now this face to this face, 2.2. So let's extrude it out by 2.1. Okay, so now we can do a circular pattern of this and this. Oops, yeah, and the axis of pattern. I don't get this. Like, so what do I have to do? I have to sketch on here and then make a fucking circle that's arbitrarily dimensioned. And then I can now I gotta go through this again. Bro, CAD in so many ways is just stupid. And then we want 2. Okay, so now let's just look at that. It says it's a little bit high, but I think that it's actually going to be fine. Oh. Is that curved? But didn't we do a min distance thing? Oh, I guess I... Wait, what? Wait, some of these faces are round and some of these faces aren't? Or are they all round? They all look round. So let's reduce that to 1.7, and then we're going to print it. So we're going to take this extrude, make it 1.7. Okay, so then after that we'll put on this thing, and then we'll design the little jig. Let's just see, what is this inner diameter, and then we can print it with it, because then we don't have to wait as long for all the boot up and nonsense. Okay, so it's like 8. And no, we know the shaft. The shaft stays the same. It's 5. So we have, okay, so what I want to do is I want to just print out, so this is going to be encoder magnet installer. And it's basically, let's see here. I mean, the first, fantastic. Thank you. Thank you. Thank you. Thank you, Firefox. Thank you. Obviously, it's my fault, but I don't care. Okay. We're close. So we're just going to make a, so this is going to be like 8 minus 0.3. And then we want it to be, we want it to be 5 plus 0.3. What's the distance between here? Like 1.2. Okay, so that's pretty thin. So we just want to extrude this, and we're just going to extrude it by, yeah, 25 sounds good. And then the magnet, I don't know the dimensions of the magnet, but I know it's smaller than 5. You know what you could do? I could make it like not a cylinder where it encases it, but more like a fork that comes down. So you plunge into it, you press it, you have it, and then you slide it out from under. So you have 2 parts. You have a plunger and then a fork that that the magnet rests on, kind of. I don't know if that's gonna work, because yeah, the reason why that. Well, the other thing is that you kind of want it to be all around, because it's gonna want to fly everywhere. So when you apply it, you're gonna want a little. So let's add the plunger too. So we're gonna sketch on here. This is going to be so let's just use this, and then we're gonna dimension this to be like, yeah, perfect, 0.3. Or actually, well, that should be fine. Then we're gonna take this and we're gonna extrude it down. I think 25, right? Well, no, we want this to be maybe like 45. Yeah, that's fine. So yeah, so you put the magnet in from the top. Oh, but you need, crap. Oh, you know what you do? No, you hold the stepper motor with the shaft, with the whatever. So you apply the glue and you get it mounted up here, and then you press it in from the top so that the magnet is being held. Yeah, because then you go like this. It's resting, it's resting, it's resting, and then you press it. The only thing is if the magnet becomes misaligned or something. So this is going to be the retainer and the plunger. Okay. All right, so we have 2 parts to print, and then we'll go from there. This is definitely an unexpected complication for sure. Wait, that's going to do it as a zip. Let's do this. Did it download? Do downloads just not work? This is the thing, man. Let's try this. Maybe it's that. But I feel like it's just Firefox being total dog shit. Will I receive a notification? Will I? Okay, whatever. Oh, it's just like, yeah, okay. Hopefully, let's see. Did it download it or not? I don't even know. Technology, bro. Oh wait, hey, it did it. It did the first one. That's so slow. Yeah, it's not even worth it. Let's see, is it in my downloads? Oh, that's such a joke. See these prompts. Ridiculous. Okay, so wait, we want this and we want this. Okay, so bamboo. So presumably, okay, so we need this, and then we need this. No. Where's the fucking other part? Oh my god. Wait, if I do this, then I go into here, and then I do this. Yeah, that's so stupid. Wait, oh wait, do I have to? Okay, hold on. Let me think about this. Like, if I, that is so crazy, bro. Windows is just so bad. Auto arrange. Okay, so presumably we might not even need. Why is my? What is going on? Okay. Let's just see if we need the overhangs. All right, cool. It's gonna put a brim on those. That checks out. But I actually want to, if that's the case, then I just want to move them out a little bit. Okay. Good stuff. So there's not really much else to do except for we could just test this encoder on its own. Okay. We might as well, but hold on. Yeah, okay, so the way that I would do this is, because the way that I did this previously is I just took a, I just took a bunch of long wires and soldered them in with no headers, but what I think I'm going to do now is, I bought this crimping tool, and it allows me to put, like, headers onto this. So that would make it really easy then if, the only thing about that, though, well, we could put it in a 4 and then just use only 2 of them. Because in this case, we have VCC out and ground, and then dir, S clock, S data, and then GPO. But we only use 4 of these. So, but we could still crimp the headers. The question would be kind of, is the wire that I have too high a gauge? Because it's 22 gauge, but I think that those little pins don't do that. I'd have to look. We might as well just get the tool instead of being a pussy and fucking around. So I gotta get the tool. I gotta find that box of crimping things with the headers, and then I guess then we just I need to remember how to use that thing basically, because I only used it once and I don't remember how exactly it works. Okay. Okay, so yeah, so here's what it is. It's this tool. It's a crimping tool specifically for this kit. I'm not sponsored. No one would ever sponsor me, but it did work out. Okay, so the only time that I used these was I used them on the main board, which is it's like in between a breadboard and a formal PCB. It's like a breadboard that you solder onto. Anyways, what I wanted to do in case any of my chips died is I put headers on it so that I'd be able to replace the chip without having to resolder the whole board. So yeah, so we're gonna take a 4 and a 3, and yeah, we want it to be female, but then what we want to do, and I forget exactly how this works. Let me watch a video, because I forget how to do this thing. There's like female and male, and I forget, because I want, because I've never done this where you put a cable on it. So let's look at this. DuPont crimp tool. I saw there was a good one. I think it was this one actually.
Looks good. Squeeze down on the crimpers to make the.
Oh, so yes, you do it on the wire. Oh yeah. You do it on the wire, but then the end of the little thing has a one-way thing. So if you yank on it really hard, it's okay. Cool. That's really nice. And then what I'm going to do, and I've never done this before, I'm also going to use zip ties because it seems like zip ties are a pro strat for cable management. Okay, so this seems like it shouldn't be too bad. I just need to remember what to do. So we need to so let's switch to our nice new camera. Let's get this out of the way. Let's get the breadboard out of the way. Get the laptop out of the way. Now we have a nice work surface that's aesthetic and pointed right at my balls. Damn. Okay. So, if I remember correctly, how does this work? Right, how did I do this before? Oh yeah, I used some wire cutters. Yeah, let's get some wire cutters, I guess. So I think, no, let me just break one off, because this is how they say to do it, but it's actually a pain in the ass to break these off. Okay, there's one. So what I think you do, let's just use some wire to test it out. Okay, so for right now, let's just get a short wire so I don't waste anything. All right. So you take this, and now you have your wire. You strip some of it, and then you like put this thing in here, right? Oh wait. Let me watch the video. Because I think I.
The device that you're wanting to connect to. Once you've chosen your connector, we can place it into our crimpers. Our crimpers have several different size presets for the different size connectors. You can also remove this screw, turn the cog, and reinsert the screw to change the strength of the crimp. This lever here allows you to release them without having to complete the crimping action. Just pull the lever upwards, like this. You start the crimping by seating the connector in the jaws of the crimper itself. The V-shaped piece should be facing upwards and pulled back so that it stops against this ridge. You can then partially close the crimpers to hold it in place. Strip about 5 to 7 millimeters of insulation from your wire, and then insert it into the connector. Check on the other side of the connector that the wire has gone inside the tunnel section before crimping. If I show you about the crimper in the way, the positioning should look like this. If all looks good, squeeze down on the crimpers to make the first crimp.
Wait, so it goes down onto the insulation though. Okay, so I think I got it. So now the thing is, if it goes down on the insulation, okay, so all right, so I think I got it. So now what do we want this final thing to look like? Because there's now a little bit of an unknown on exactly how we want this to work out, because well, yeah, let's just make the wires. So if we look at our breadboard, where's our breadboard? If we look at our breadboard, we have the stepper here. We're going to have, I guess, maybe wires coming out here. So the breadboard's going to sit like this. And the motor's going to be here. And I was thinking of designing a nice little case for it, because Curious Scientist did a really good job of making a clean little thing that showed you how you could play around with it. And I kind of like that. The point is, the motor's going to be here, plugged in. Okay, then standing on the motor, raised up a little bit, is going to be the other thing. So now there's going to be cables coming here to here. I think we could just make them short. So not this short, but like maybe 3 times that length, 4 times that length. And now it's going to be pretty important to get... Okay, so let's do it arbitrarily. Let's do it this length. Maybe, I don't know, this length. I'm going to get it exactly right. Because it's so annoying when the cables are slightly different lengths. This is why I kind of wish there was like a... Okay, and now we need a green and a yellow, I think. I forget what the colors are for... Let me just ask ChatGPT. I always forget. Yellow and green. So the clock is yellow. Okay, and then green. Even though it's so tedious, the zip ties, I think. The thing is, my guess is that like this is much thinner. Oh, and This is oh, this is solid core. I should get a pack. I don't know if I have a pack of 22 gauge. The thing is, can you use stranded? Can you use stranded with DuPont crimp? Yeah, you can. I need to go look and see what packs I have because I've been collecting wire. Because honestly, getting the right wire, it saves you a headache down the line. Like if you just like right now, I think I have like stranded and non-stranded 16 gauge. I have a bunch of boxes. I have two boxes, both of them partially used of this 22. I found 22 is like the best for just normal breadboards because it's not like too weak that it falls out all the time, but it's not too okay. Okay, so what we're gonna do here is we're just gonna do this manually because I don't really. Think 4 of them is going to take that long. Fuck it, I'm getting the thing. It's so annoying. I remember I had to do 50 of these. Something like 50 of these. And it was brutal. No, was it? No, it was like I don't remember how many it was. It was a lot though. It was definitely more than 50. Okay. So we're done with this entirely. I forget how much I paid for this, but I think it came with the tool. Anyways, it's definitely a nice tool. So okay, so now we need to get the pinouts right. So where's the chip here? Okay, so we need to so what do we want? We want this thing to be plugging in to this like that. Wait. Wait, this isn't. Oh no, that's dude. I'm so stupid. Okay, it's because I was like, why is this thing falling out of here? It's because there's nothing in it. Anyway, so yeah, so we want VCC to be on the top. So let's just crimp these bad boys. So we need to crimp city. I forget how I got hella pro at this. Oh yeah, this is what you do, I think. You got to go left-handed. Then you get it down into one click. Then you move it out. Then you straighten this out. I never did this with the wires before. I only ever did it with the without wires. Oh fuck. Oh fuck. Oh, there we go. That's not moving. And then I'm gonna do both, I think. Yeah, that's not going anywhere now. Oh, but actually, it's kind of a tenuous electrical connection. Don't you want...
The positioning should look like this. All looks good.
Alright, it's probably fine. So then you slide this thing in here. And it snaps together and then it can't come out. I mean, it can come out a little bit, but not really. So now when I put this in here... Oh yeah, that's a fantastic connection. That's exactly right. Nice. Good stuff, man. Okay, so you left-handed. You come in here like this. Oops. Fuck. Okay. Oh, I broke this one. Wait, did I? Yeah, I tried to crimp it up ahead, but alright, so this is junk. So I need to get another one of these things. Why waste the wire though? Whoa. Okay. Yeah, I'm being overly... He's using solid cord wire, right? Stranded would be nice because definitely the wire in here is stranded and it's just so stiff. I'm probably going to buy a pack. There's something else that I needed to buy. Oh yeah, a filming mat. I was going to buy a filming mat so that you don't see my balls all loose when I'm filming. Unless you guys want that. Unless anyone's looking for some balls. Get it in there. Yeah, the point is, you gotta be careful not to damage the, I just wonder about the electrical connection quality. But oh, wait, what? It comes out so loose. Yeah, if you just bend it the other way, it just comes out. I think I shouldn't. Let's see. Let's see how good this one is. Oh, that one's good. Yes, I'm not sure what I messed up, actually. But yeah, we're gonna need to Dude, I feel like I was so much better at this the other time I did this. It's so hard to get it like right in there. Yeah, it's probably good. Maybe one more. One more click for good luck. Isn't it? Okay, now at the very end, you don't want to crimp the good part. You just want to tighten down the end part. Okay, let's see. Let's hoping and praying. Okay, that's pretty good. This thing isn't really going anywhere. Which is awesome. So now all we have to do is to plug into this thing is, oh, but it's loose. What? Let's see if we can get it out of there. We can't get it out of there, but it's, let's see, what about 22 gauge?
U-shaped piece should be facing upwards or back slots against this ridge. You can then partially close it to hold it in place. Strip about 5 to 7 millimeters of insulation from your wire, then insert it into the connector. Check on the other side. If I show you about
God damn it. What? Let me think. Okay, so I have these headers. How are these headers? Did I just mess them up, though? That's what I feel like I did. I don't know. I feel like... Dude, I want to do a video on the history of connectors. Because connectors are actually really interesting. But this is definitely not it. Something's going wrong. Um... What if I put like a long... What if I put like this in there? There's just no grip. Somehow I must have... I think I just making him... Well, no, but the pins aren't that long. Oh, crap. Okay. All right, the print is done, so... Gosh, this is a pain in the ass. Should I keep trying it, or should I give up? I'm going to try to make the wire shorter, maybe. I really can't tell why these are so loose. Okay, what we're going to do is strip way more insulation. Because the thing is, the thing is that it's let's see. The distance that you need to go into this thing to have it engage is a couple millimeters, and then it really comes down on it, and it's nice. It's a good amount of... The problem is here, you're not getting to that point. So, so for something like the chip, which doesn't really have that long of prongs, it's just sort of floating around in there. Let's see if we can get this out of here. There we go, there's one. Probably damages it a little bit, but what we're going to do is, well, let's get this piece. We're going to crimp one that's like, with like way more insulation exposed. Or wait, is that what we want? It needs to grip the insulation though. But it needs to be able to go... Okay, you know what I want to watch? In his video... Yeah, you know what? I think low-key, the wire gauge I'm using is too big because... Well, that's not actually true because this wire gauge does fit in there. It's only when it's squished down. So if we go back to this thing, if we just really force it to go forward, maybe we can... There we go. That's what we want. That's nice and strong, actually. So you just need to force it. Ugh. The problem is I feel like it could come loose. But I feel like now that I've pushed it in there a lot, this thing might actually hold. Oh, yeah. Honestly, I'm still a little suspicious, but... Okay, well, let me get a voltmeter, and we're going to do a little continuity test. Okay, so I have the 3D printed parts, and we are just going to do a little test right now with that. Okay, so the idea would be I didn't get the magnet, but you'd... Oh, and actually you'd probably want a stopper, right? Yeah, you probably want a stopper. But the idea is you put the magnet in there. Yeah, so we're okay, so we'll add a stopper. This stopper is nothing. This is just the brim. So yes, you put the magnet in, you put the glue on, and you line it up, and then when you're ready, you push it on. And then hopefully you wait. And I don't know how long you wait. No way, Curious Scientist does a video about crimping DuPont? Dude, he has such long videos, but they're always so good. Bro, Curious Scientist is actually goated. What the hell? Alright, so let's just do this electrical test. And then we're going to do the other two. And then go from there. Okay. Alright. So we go to this, and then if we touch them together, let me look at my shot. Let's see what's in frame. Got my multimeter in here. Okay, that's doing... But how do I get the... There we go. You should be able to hear that. Okay, so now I'm going to take this, take the top of it. I probably won't be able to loop on all that well. So let's loop onto here, and then we'll test on the other one. So we're doing VCC. Yeah, did we connect this right? Okay. Okay. All right, cool. So I'm pretty confident that you just got to shove it in there. Maybe we'll test the other ones, but I feel pretty good about that. Okay. Oh, I forgot the toothpicks. Okay, so don't we want to do it on this side too? Yeah, we do. And we want to try the male ones. Ay, ay, ay. Suddenly this has become more work than I wanted. Okay, so yeah, so we want to put... So this is going to be sitting like this. So imagine that we have this here. And we're going to need to put it on top of here. All right, so why don't we just do it instead of complaining about it. All right, so let's do this one. And then let's break out some more of these guys. Wait, I need 2, 4, 5. I need 6. All right. Wait, I was disconnected from chat? Wait, why don't I have chat? Oh, there we go. Okay. Get out of there. Okay, so where's our 4-pin guy? So now our chip. Oh yeah, you don't want to make it too long. Otherwise it goes in there. I think I might have made mine too long. Anyway, so this is going to be in there. Oh wait, I did this wrong. Okay, whatever. This is going to be in there like this. So wait, which one is data? Clock is yellow, right? Okay, so clock is yellow. So we want to put the second one down. Oh, that one worked pretty well. Wait, did it? No, I don't think it did. It's all right. It's all right. It's not the worst. It's not incredible, but it's not the worst. But I am going to take a little bit off of this thing. Okay, so let's get another one of these guys. Bro, this process is boring AF. But it will be cool when it's done. Okay. The pull from this side, from here, is pretty good, but yeah, I mean, I gotta go look for some stranded wire. Otherwise, I'm gonna buy some.